This video originally had a watermark, not a static one, but one that moved with the footage. With traditional methods, you'd have to fix it frame by frame, spend hours on it, and it still might not come out clean. But this time, I did just one thing, one click, and the entire video was processed, faster than ever. In 1080p, and even 4K works. This time, I used SAM 3.1. More importantly, this kind of technology can now run locally. So instead of just talking about how powerful it is, I wanted to test something. Can it actually handle real video restoration? Hello, welcome to Smart Vision. On this channel, I keep sharing the latest AI tutorials and practical tools. All workflows, materials, and resources from this video are on my Patreon and are available to download after you register. For supporters, I provide extra professional tools and deeper guides. If you like this content, consider subscribing and supporting the channel. Now let's get started. Video watermark removal has always been a pain, mainly because of the trade-off between quality and speed, especially when the camera is moving, the background is complex, or people are passing through the scene. The traditional workflow usually involves tracking a mask, constantly adjusting it, and then patching the image bit by bit, which ends up being extremely time-consuming. From my previous experience, this kind of process feels more like something you experiment with, rather than something you can actually rely on in real production. What SAM 3.1 does, however, is surprisingly straightforward. It understands objects in the scene, so you can simply type watermark, and it will automatically identify it across the entire video. After that comes the restoration, and only when these two steps are combined do you get a complete, usable workflow. Now, let's briefly look at this from a paper perspective, why SAM 3.1 is so powerful this time, and more importantly, why it can actually be used for video restoration. The key shift is that it's no longer just a segmentation model. It becomes a unified system that handles detection, segmentation, and tracking all at once. Previously, these steps were separate. You had to detect objects, segment them, and then track them using different methods, which made the whole pipeline fragile and hard to scale. SAM 3 changes that by integrating everything into a single model. More importantly, it introduces a memory-based tracking mechanism, meaning the model doesn't reprocess every frame from scratch, but instead remembers what it has already seen. That's why you only need to click the first frame, and it can follow the object consistently throughout the entire video. Each object is assigned a persistent identity, and this is exactly what makes video restoration stable, because as long as the identity holds, the mask doesn't drift. Another major improvement is concept-level segmentation. Instead of relying purely on points or bounding boxes, the model understands what you're selecting at a semantic level. So when you input something like watermark, it's not just selecting pixels, it's recognizing a category. This is why it performs much more reliably in complex scenes, and also why you don't need to train a custom model beforehand just to define what a watermark is. The training cost essentially drops to zero, which, honestly, is great. There's also a factor that's easy to overlook, but makes a huge difference in practice: speed. The improvement here isn't just about stronger compute, it comes from a fundamental change in how the computation is done. Traditionally, segmentation runs frame by frame, so the total cost scales directly with the number of frames, which is why the process is so slow. SAM 3.1, however, avoids recomputing everything. It treats previous frames as memory and only updates what's necessary in the new frame. A simple way to think about it is, instead of redrawing every frame from scratch, it refines the previous result. This significantly reduces computation, and because detection, segmentation, and tracking are all handled within the same model, there's no overhead from switching between different systems. The end result is not just better stability, but also a much faster overall pipeline. We need to install Comfy UI. If you have an NVIDIA GPU, search for Comfy UI on Google, open the site, and download the appropriate version. If you have an AMD GPU, download the AMD portable version of Comfy UI from the Comfy UI GitHub page. After downloading, extract it, and it will be ready to use. I'm only giving a brief demonstration here because I don't have an AMD GPU and haven't tested it myself. Also note that some Comfy UI custom nodes may not support AMD GPUs, so keep that in mind. The latest version natively supports SAM 3.1, which shows the Comfy UI team also sees its importance for AIGC workflows, especially for automation. Basic usage is very simple. Open the Comfy UI template, enter your prompt and click Run. SAM 3.1 will select your target and output it as a mask. One thing to note about prompts, you should write them in a structured format, one target per comma. Not natural language like everyday conversation. Alright, that's all, thank you. Just kidding. That part is almost too simple to even talk about. What's really interesting is what comes next, video restoration. Especially in high resolution, like 4K. Let's start with a quick introduction. This workflow consists of two main modules. The first module uses SAM to extract the target mask from the video. The second module uses ProPainter to remove the watermark. Alternatively, you could also use SDXL to remove the watermark frame by frame. First, load the video. When doing so, make sure to set it to read 16 frames per batch. This is handled using the Meta Batch Manager node and helps prevent OOM issues. Next is the SAM3 prompt. In my case, I'm removing my own watermark, so I describe it more specifically, for example, Smart Vision watermark. If the prompt is too vague, SAM may also detect and mask other similar text, which can lead to unintended removals. In the second module, pay attention to the ProPainter node. Increasing raft ITER can improve the quality of watermark removal. It's also important to note that the ProPainter used here has been optimized. You'll need to download the model and place it in the Comfy UI, Models, ProPainter directory. The optimized version automatically releases VRAM after each run, which the original version does not support. More importantly, I've added several exception handling mechanisms to deal with edge cases and prevent the workflow from crashing. For example, situations where the mask contains only a single pixel can now be handled correctly. Also, make sure the Video Combine node is connected to Meta Batch Manager. I ran 3 sets of tests from simple to more challenging. First, static background. One click, and it's basically clean, you can hardly tell it was edited. Second, moving camera. This is where things usually break. But the mask stability here is actually quite solid. Most of the restored frames look natural. Third, the extreme cases, where people move through the scene, the background keeps changing, and everything is in high resolution. At this point, the overall result is actually quite good, and it's hard to immediately tell it's been edited. Of course, there are still some areas where it looks a bit blurry or less natural. But overall, it has reached a level that's usable in practice. If the video is longer, the processing time will still increase. So I wouldn't say it fully replaces manual work yet. But it does compress what used to take hours into something you can finish with a single click, in just a few to maybe 10 minutes, with results that are already quite solid. But the most important part isn't watermark removal itself. It's that AI is starting to understand video content and manipulate it consistently. And that's the real shift happening here. At this point, you've probably realized that this workflow actually works. But once you try it yourself, a few issues show up pretty quickly. It can be slow, the masks aren't always perfectly stable, and at higher resolutions, you may start to notice occasional artifacts. So I ended up building my own optimized version, mainly focused on improving speed and stability. The free version will include the basic workflow, which you can run directly without any problem. But if you're planning to use this in production, or simply don't want to spend time tweaking parameters, I've put the optimized version on Patreon. It includes acceleration, more stable masking, and better handling for high-resolution footage. You can watch this video first, and then decide whether that version makes sense for you. That's it for this episode. If you enjoyed it, please like and subscribe. All resources will be shared on Patreon. If you're interested, feel free to support. Thanks for watching, and I'll see you in the next one.